Hi, everyone. Welcome to part 2 of our Unit 5 notes. We're going to pick up where we left off, which is with number 8. So we're given a quadratic function, and we are asked to find the x-intercepts and the coordinates of the vertex. So a little refresher about understanding these directions. For x-intercepts, we need to factor and then set h equal to 0 and solve. And for the coordinates of the vertex, we're going to first find the x-coordinate, then we'll find the y-coordinate by plugging in whatever we get for the x-coordinate. So if that's enough of a refresher from Algebra 2 for you to do this on your own, go ahead, click pause, try it, and let's see if we match. Everyone else, let's do it together. So first, let's find our x-intercepts. Okay, so I have x squared minus 4x minus 5 equals 0. So this is nice because I have a leading coefficient of 1, which means only x times x will work, because that's x squared. 5 is prime, so only 5 times 1 equals 5. So 5, 1. Now, I need to check, does inner plus outer equal middle? So inner plus outer, that's going to be 5x and 1x. Now, we need those to combine to be a negative 4x. So which one needs to be negative? The bigger value. Negative 5 plus 1 is negative 4. So I need a minus 5 and a plus 1, and that equals 0. Okay, if I was only being asked to factor, that would be all I would need to do, but that's not it. So next, we need to take these factors and actually get the x-intercepts. So we have x minus 5 equals 0, and x plus 1 equals 0. So we're going to solve. We get x equals 5 and x equals negative 1. So for my ALEKS answer, it asks for them to be separated by commas. So I would type in 5, comma, negative 1, and that is it for x-intercepts. It doesn't matter if they're in order, smaller, bigger, bigger, smaller. Okay, next, let's do our vertex. So step 1, find the x-coordinate. X equals negative b over 2a. Just as a refresher, standard form is, let's move that up a little bit, ax squared plus bx plus c. So notice a is the number in front of x squared, so there's a 1 right there, b and c, and we can actually write that down. A equals 1, b equals negative 4, and c equals negative 5. You'll remember that from number 7 because you needed to know that to do quadratic formula correctly. Okay, let's continue. Notice this has a negative, so we're going to make sure it doesn't disappear. Bring over the negative, parenthesis. B happens to also be negative over 2a, and a is 1. Negative times negative is positive. So the x-coordinate of my vertex is 2. To find the y-coordinate, we're going to substitute the x-coordinate into the function. So we're going to do y equals 2 squared minus 4 times 2 minus 5. And then we're going to simplify. So that equals 4 minus 8 minus 5. Remember order of operations, we do subtraction in order from left to right. So negative 4 minus 5, giving me negative 9. So there are the coordinates of my vertex. So my final answer, 2, comma, negative 9. Done. Okay. Number 9. Use a graphing calculator to find the x-intercepts and vertex for the quadratic function. That's the function. Round the answer to the nearest hundredth. So remember, nearest hundredth is 3 decimal places. If there's more than one x-intercept, sorry for the typo, separate them with commas. Okay, this is a graphing calculator skill question. Unfortunately, I can't pull up Alex's graphing calculator in these notes. So I will tell you what the answer should be so that you use the worked example. Well, actually, I think I can pull up the calculator. Hold on one sec. Just going to quick pause. Okay, so I just logged into a student's assignment. Thank you, Julissa. Her function is different from the notes, so I'm just going to cover it up. This is strictly to show you how to use Alex's graphing calculator. You have the function in your notes, so we're going to go to y equals. And how can I get this to fit? Let me zoom out a little bit. There it is. Okay, so we're going to type in the function 4x squared. So 4 help if I was in the box. There we go. 4x squared. So you can use your keyboard, otherwise use the variable right there. 4x squared plus 10x plus 10x plus 2 and graph. Okay, so there's my graph. We can zoom in a little. So here are my x-intercepts, and here's the vertex. So if I zoom in too much, I cut off the vertex. So maybe I'm going to zoom out just a little bit. So maybe I'll leave it like that. Okay, so first let's find the x-intercepts. So we are going to go to calculator, 0. Zeros are your x-intercepts. So the nice thing is you can either type in your bounds, or if you'll notice, I can actually drag them. If I can click on it. Okay, typically you can drag them. Otherwise, you can just type in the values. So these dotted lines are like Jersey barriers. They should frame the x-intercept you're trying to find. So that's the one I want. So I click on new, or excuse me, I click on 0, and there it is, negative 0.21922. So our first one is negative 0.21922. So if I need this, I'm sorry, hundredth, 2 decimal places. My apologies. Okay, that's not working. So I will just rewrite it. Hundredth is definitely 2 decimal places. Okay, so to round this, if I need 2 decimal places, we look at that third number. If it's 5 and up, round up. So we're going to round this to negative 0.22. So that's my first x-intercept. Okay, let's go back to the graph. I'm going to click on new. See if, maybe if I use the mouse. There it is. Okay, so click on it, and now I can drag this to the left, and then drag that one also over to the left. So now they're on either side of my other x-intercept. So when I click on 0, there's my other x-intercept. So we have negative 2.280, negative 2.280. So that's going to round to just negative 2.28. So for my final answer, just make sure you separate them with a comma. So negative 0.22, comma, negative 2.28 is how you would type it into ALEKS. For my vertex, instead of calculating it by hand, now we can use the ALEKS graphing calculator. So let's try to zoom in just a little bit more. All right. So for the x-intercept, we're going to go back to calculator. For the vertex. This time, we need a minimum or a maximum. So that's called an extrema. And notice, now I have the option, minimum or maximum. So this opens up. Because it opens up, it has a low point. It has a minimum. So I'm going to drag my two parameters so that they frame the minimum. Click on New. And it's -1, -4. Right there. See the results? -1, -4. Hold on. My answer is different. That should come out to be a decimal. So I'm using a recording device, so this mouse that's moving isn't really a mouse on my end. So I'm just going to click pause and use the actual mouse. Okay, so now I'm actually using the actual mouse on the computer, and it worked much better. So New, I'm going to drag. And then because it's a minimum, I'm going to click minimum. I might have clicked maximum before. Maybe that's what happened. But click minimum, and there it is. -1.25 and -4.25. And that's it for number 9. The graphing calculator does all of the work. So for number 10, we're going to analyze the function a little bit more. So we're given the function, and A asks, does it have a minimum or a maximum? You can tell that by the sign value of your leading coefficient. If A is positive, it opens up. That would be a minimum. If A is negative, it opens down. That would be a maximum. And if you want, instead of fitting this in such a small space, we do have plenty of space below. So for part A, if the leading coefficient is positive, it opens up. So that means that the vertex is a minimum. If it's negative, it opens down, vertex is a maximum. And when we say leading coefficient, remember, we're always talking about standard form. So if I have y equals ax squared plus bx plus c, we are referring specifically to a. That is your leading coefficient. So if a is positive versus negative. Okay? So that was the bell, so I'm just going to finish up part A. It opens up. So we have a minimum. Okay. What is that value? Well, we actually need to calculate the vertex. So we did that together in number 8. So if you can click pause and try this part on your own, that would be great. Otherwise, let's do it together. So remember, the x-coordinate is negative b over 2a. Looking at this function, I know a equals 2, b equals 16, and c equals 36. So let's plug that in. That's going to be negative 16 over 2a, negative 16 over 4. So the x-coordinate is negative 4. Okay, now b and c have a slight difference. B says what is the function's minimum versus where does it occur. So what is it versus where? The where is the x value. So x equals negative 4. That's the where. The what is the y value. So let's write that down. What versus where? When it asks where, it's asking for the x coordinate of the vertex. If it's asking what, it's really asking for the y coordinate of the vertex. Okay? So when we start, we actually found the answer to C. Now let's find the answer to B. Let's go ahead and find the y coordinate. So if x equals negative 4, we plug it back in. So when we say y, we're also, for practice of function notation, it's f of negative 4. So 2 times negative 4 squared plus 16 times negative 4 plus 36. Okay, please click pause. Go ahead and simplify that on your own. So you should have said 32 minus 64 plus 36. So that's negative 32 plus 36. And that comes out to positive 4. So again, just for emphasis, where does it occur? At the x-coordinate. What is it? In terms of what is the min or max value, that's the y-coordinate. Okay, so that's it for part 2 of our notes. That's numbers 8 through 10. Part 3 will be posted later on today.